Welcome to the FactoryHelp channel, Mixed Flow Fans. An axial fan is a highly efficient, lightweight way of generating a high airflow in an axial direction. The flow of air enters and exits the fan axially. Still, it can struggle with high pressures from restrictions caused by fixed or variable airflow resistance. It is, therefore, critical when selecting an axial fan to understand the airflow restrictions and not operate the fan at a point that will cause it to stall. Using an airfoil section is the most efficient way to generate airflow, giving the most flow output for the minimum power input. This makes an axial fan the perfect choice to produce high airflow in a compact, lightweight package. However, like an airplane wing, a fan blade will stall and stop generating flow when it encounters certain conditions. For a fan blade, a stall condition occurs when the pressure upstream of the fan becomes equal to the pressure downstream of the fan. High pressure is generated upstream by anything resisting the airflow, including fixed grills, electronic equipment, or variable resistance like a filter that's slowly blocking over time, or passengers opening and closing gaspers in an airplane or car ventilation system. A centrifugal fan works using a different set of principles. Air is drawn into the fan axially and exits radially. Air trapped between the fan blades and the fan's outer casing or scroll is thrown out radially when the fan is spinning. The exiting air volume leaves a vacuum, drawing in a new packet of air to replace it. The air flows around the curved walls of the scroll, and the air exhausts radially because they use centrifugal force rather than an aerodynamically efficient airfoil blade. That brings us to the mixed flow fan, and as its name suggests, this type of fan combines elements of an axial fan and a centrifugal fan. So how does that work? The fan uses an efficient airfoil blade, like an axial fan, but wider and arranged around a conical hub. Combining these features generates a flow typical of an airfoil blade, but forcing the air to flow past the cone introduces an axial and radial characteristic to the airflow. The net result is a fan capable of producing high airflow whilst dealing with high pressures caused by upstream airflow restrictions. Another benefit of a mixed flow fan is its ability to exhaust airflow axially or radially, making it highly adaptable to tight spaces where axial flow is impossible. Finally, because the blades of a mixed flow fan are short and stubby with a broad airfoil section, they are much less sensitive to particle erosion compared to an axial fan, whose blades are long and thin. This makes them ideal for use in sand and dust-laden environments, such as sand scavenge applications. Due to their aerodynamic characteristics and lower operating speed, mixed flow fans are also quieter than axial flow fans, which generate high-pitched frequencies as their blades pass by a stationary guide vane. In summary, a mixed flow fan can deal with high pressures and produces high flow rates needed for cooling. Confidence comes from knowledge. Learn with us. Become an expert in industrial solutions.